So let's look at this question here, which was taken from the year 2010, paper 1, question 4 of the A-level H2 math paper. So given that x squared minus y squared plus 2xy plus 4 is equal to 0, find dy dx. I think we're just going to use implicit differentiation. So this case here, we're just going to differentiate with respect to x because we want to find dy dx, right? So that's that. So shouldn't be an issue. Implicit differentiation is just as per usual, but if you were to see a variable which is not x, we just need to add dy dx behind because of the chain rule, right? So this case here, for the first one will be 2x. Then the second one, differentiating y squared will be 2y. But because this is not x, so we just put a dy dx behind. Okay. Then for the subsequent one, okay, this one probably have to be slightly careful. We need to use product rule. Differentiating 4 is just 0, it's just constant. Okay. So this guy, what I have here is a uv. Okay. So you use product rule, differentiate the one on the left, keep the one left, differentiate on the right, plus keep the right, differentiate the one left. So u dv dx with dy dx plus y dx dx, which is 1. Okay, this is 0. Then we need to make dy dx a subject. Okay, so there's that. So I get this expression here. Then I'm gonna make dy dx a subject. You just factorize and then just divide. Move the rest to the other side and just divide. So from this case here, could you factorize the 2 out and then just simplify it, right? Right, that's the answer there. Okay, great. Now we try to understand the second part. The second part for the curve with this equation, find the coordinates of each point which the tangent is parallel to x-axis. Basically what happens is we know that this is dy dx, all right, and then we're not sure what kind of curve is this. This is some curve which is some form of curve here, but actually what we can do, just to some curve, okay, doesn't matter what curve it is, but we would use decimals and sketch it out. It's actually sort of like a tilted hyperbola. Okay, so there's a horizontal, there's an oblique asymptote here, and so on, right? So the idea is essentially we need to find out what is the tangent which is parallel to x-axis, which is dy dx equals to 0, right? Essentially, this is what we learned in secondary school as well. So let's say this curve here. Okay, I'm not sure how this curve looks like, but generally we need the gradient here to be okay, maybe we just do this out. We need this to be parallel to x-axis. Okay, if it's parallel to x-axis, is obviously dy dx equals to 0. Okay, so dy dx equals to 0, right? Okay, so we will let dy. So what you need to understand is that if dy dx equals to 0, the denominator is also 0, so x plus y plus x is equal to 0. Okay, because basically this would mean that whatever point on the curve it is, it will also satisfy this equation here. So just understand that from decimals, from the curve that we sketch here, okay, whatever happens, okay, we will write y equals to minus x. This equation here is nothing more than this line equation here. You see this? So essentially you can see that the max mean point satisfy this point here. Okay, so remember what we actually need to do is to substitute y equals to minus x back into the curve equation, because the point where it's parallel to the x-axis is where it satisfies y equals to minus x, but and also it satisfies back the equation of the curve. So this is the equation here. Substituting back shouldn't be an issue. All right, then you're going to solve this equation. So you get x squared equals to 2, so x will just be plus minus 2. Then we know that okay, use the linear equation to solve our y, because you don't want to have a situation where you have you need to reject one. Linear is easier because it's only one solution there. So I'm going to use y equals to negative x. So when x equals to root 2, y equals to minus root 2. Then when x equals to minus root 2, y equals to root 2. Okay, minus. So imagine, okay, so now back, basically conceptually, it just means that if I were to put these two equation here, this is my minus root 2, which is root 2 is 1.4. Yeah, this is root 2 minus root 2. Okay, so the answer is correct in that way. Okay, so that's the coordinates that we have is root 2 minus root 2 and minus root 2 root 2. Okay, so that's how you do this question here proficiently. If you have any questions, please do let us know, and I'll see you in the next question.